Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 2, Lesson 2, Parallel and Perpendicular Lines. The essential question for today is, how can you determine the relationship of two lines by looking at their slopes? Today we're going to focus on looking at parallel lines and perpendicular lines. When we're thinking about their slopes, we're thinking about the tilt of the line. So we're thinking about those positive, negative, zero sloping lines, as well as undefined sloping lines. We will need to recall some information from algebra, as well as your geometry classes. What we'll be doing is calculating the slopes of lines that are given to us. There's two ways that we can calculate these slopes. One way, if we're given a graph, we have line 1 and we have line 2. On this particular line 1, what we can do is identify two clear coordinates that are definitely on the definitely on the graph. So for instance, this point here, -3, 0, and this point here, 0, 2, are definitely on the line. So with the 2 points, you'll start with the one that's on the left, which is here, -3, 0, and we're going to travel to the one that's on the right. What we'll be doing is calculating the rise over the run. So we would have to rise by 1, 2, so rise by a +2, and then run by 1, 2, 3 to get to our next point, the point that we've identified here, which is 0, 2. So then in this case, our slope for line number 1 would be a +2 over 3. We rose by 2, or we climbed by 2, and then we ran by 3. For the next line, line number 2, we do the same thing again. We identify 2 points that we can clearly see on the graph. Here's a point here, and here's a point. Now, if you're looking closely at this graph, you'll also notice that 3, 1 is also a point. It doesn't matter what 2 points we actually choose, because on this particular line, any 2 points will have the exact same slope. So let's go ahead and count our rise over run for line number 2. So we have a rise of 1, 2, and we have a run of 1, 2, 3. So our rise is 2 over 3. This was for line 1, and this was for line 2. And there's a space to write it below. The slope of line 1 was 2 over 3. And the slope of line 2 is also 2 over 3. Okay, so notice that they're exactly the same. The y-intercept of line 1. Y-intercept means where, I'll write that note. Y-intercept is the place where the line crosses the x, y, not x, y axis. And so in this case, here is our line number 2. Our line number 2 is crossing this y axis right here at the point -1. So line 2 crosses at -1. And then line 1, the top line, crosses the y axis at the point 2. So this is a 2. So one characteristic that you'll notice about parallel lines, and this is all parallel lines, whenever you have a set of parallel lines, they will have the exact same slope. So in this case, line 1 had a slope of 2/3 or 2 over 3, and line 2 also had a slope of 2 over 3. Okay, and then they had different y-intercepts. So it was like taking one line and then translating it down by 1, 2, 3 units, and then we have our second line. but parallel lines do not intersect. They have the exact same slope. Now, if you can recall back to the first lesson, we did talk about how to calculate the slope of lines. And we used the formula m equals y2 minus y1 over x2 minus x1. This particular formula will actually help us to find the exact same value 2 over 3 for this, for either of these lines. But if we just look at line number 1, and I'll erase some of the distractors here, some of the things that we don't necessarily need at this point. All right, and then if we identify these two ordered pairs, this one is the point -3, 0, and this one is the point 0, 2. We label both of them. You can say that this one is x1 and y1, and this one is x2 and y2. Let's plug them into the formula we learned in the last lesson. y2 is 2, so we'd have 2 minus our y1 is 0, divided by our x2, which is 0, minus our x1, which is -3. Remember, minus a negative turns into addition, so we're adding. So we'll have 2 minus 0, which is 2, over 0 plus 3, which is 3. Well, would you look at that? We have the exact same value that we calculated when we calculated the rise over run. So this formula, m equals, or slope equals, y2 minus y1 over x2 minus x1, as well as m equals rise over run, are two formulas that we can use in order to calculate the slope. So please keep that in mind. So if we look at some perpendicular lines create 90-degree angles. So here we have a 90-degree angle, which we also call a right angle. It's important to note that these two perpendicular lines have created 4 right angles. So all 4 of these angles are actually right angles for 90 degrees. All right, so what we're going to do is calculate the slope of line 1 and then line 2. So for line 1, first off, we need to find 2 points that are on our line, with 2 ordered pairs that we can definitely see are there. So like this one is the point 0, 1. And if we look up and down our line, we'll spot another one here at 1, -3. So those are 2 points that are definitely on our line. Okay, so if we are endeavoring to figure out the slope, what we're going to do is find the leftmost point, and the leftmost point is here, and we'll travel it down to our right point. So start with the point on the left, travel it to the point on the right. So from this point, we will need to go down by 1, 2, 3, 4. So going down is a -4. But then we went to the right by 1, so that we denote as a +1. So when we're thinking about our formula rise over run, in this case we didn't rise, we fell, but we fell by a -4. And then our run was by a +1. So a -4 over a +1 simply just turns into a 4 over 1. Or you can say, a -4 over 1. Or you can say that this is simply -4. So -4 over 1 is our slope. So -4 or -4 over 1 is our slope for our first line. So -4 over 1, which is equal to -4. Okay. Let's also take care of the y-intercept for line number 1. Our line here is crossing over our y-axis right here at the point 1. So therefore, our y-intercept for line 1 is 1. Let's look at line number 2. Line number 2, again, let's identify 2 points that are definitely on the line. We have one here, which is at -4, -3. And we have another one here at 0, -2. Once again, any 2 points that you choose on the line, it will be fine for calculating the slope, as long as it's a definite coordinate that you can identify. So for instance, we could have also identified the point 4, -1 here, and used it to figure out our slope. In fact, we'll show you how that gets you the exact same answer as well. So start with your left point, which will be this one here, left point, and then travel to the right. So we have to go up 1, so up 1, and then we have to travel to the right by 1, 2, 3, 4. That's a +4. So in this case, our slope equals 1 over a +4, which is just 1 over 4. So line 2 has a slope of 1 over 4. Right, just to show you that you can get the exact same slope if we had have chosen this point here, 4, -1, and let's say this first point down here, and let's erase the extra. We would have had this first point going from the left to our right point. We would have gone up by 1, 2, so up 2, and traveled to the right by 1, 2, 3, 4, 5, 6, 7, 8. So a +8. So in this case, it would have been 2 over 8. But what is 2 over 8 reduced to? 1 over 4. So you get the exact same thing. Whichever 2 points that you choose on your line, and you calculate the rise over run, you'll get the exact same answer as soon as you simplify your fraction. Right? And then the last piece of information that we needed to identify for line number 2 is the y-intercept. The y-intercept is looking at where does our line cross over the y-axis, and it crosses over here at -2. So in this case, our y-intercept is -2. Right, there's something special that goes on with the slope of parallel lines, which we looked at that says that the slopes are the same. And then perpendicular lines have a special relationship too, their slopes. We'll talk about that shortly. Okay, but just examining once again, we got a -4 over 1 and a +1 over 4. Okay. Let's look at our definitions for parallel lines. Parallel lines, as we've talked about, are lines that never intersect. Okay, 2 lines are parallel if they have the same slope. In our example up here, both of our lines had a slope of 2 over 3. Perpendicular lines are lines that intersect at a 90-degree angle. 2 lines are perpendicular if they have slopes that are opposite reciprocals. Okay, opposite reciprocals. That word opposite and reciprocals is something that we'll need to explore a little bit more just to make sure that you understand what it actually is. So the word opposite. For the word opposite, I want you to think about the words positive versus negative. Okay, so opposite means one is positive and the other is negative. So one value is positive, but the other value is negative. For reciprocals, I want you to think about, so think 2 flipped fractions. Okay, so for opposites, think about positive versus negative. For reciprocals, think 2 flipped fractions. So opposite reciprocals. So for instance, earlier we got the 2 numbers -4 over 1 and 1 over 4. So here we had a fraction. It was 4 over 1. It's negative. The other one, we have a fraction, 1 over 4. It's a positive fraction. So in this case, they have the opposite thing going on. One is negative, and then the other is a positive, 1 over 4. And then they also have that reciprocal thing going on. 4 over 1 versus flipping it, which becomes 1 over 4. So these would be considered as opposite reciprocals. Opposite reciprocals. One is negative, the other fraction is totally positive. And then we also have our numbers have been flipped. 4 over 1 is the same, or is the flipped version or reciprocal of 1 over 4. So if you are given the equations of the lines, to decide if the lines are parallel or perpendicular, what we're going to need to do is write or rewrite our equations in slope-intercept form. If you can recall, that's y equals mx plus b. So we'll be solving equations for y, and then we'll compare the slopes. If you are given 2 points, then we're going to use the slope formula for each set of points, and we don't need to write the whole equation for that. We'll just need to find the slope formula, and then use the slope formula, and then determine whether or not those two slopes are the same or if they're opposite reciprocals. So let's put this all to the test. So our first examples state if the following are parallel, perpendicular, or neither. Recalling. Parallel, they'll have the same slope. An example would be like saying that one slope is 2 over 3 and the other slope is 2 over 3. So both have the same exact slopes. Perpendicular. In this case, we're looking for opposite reciprocal slopes. So that an example would be one is a 1, let's say 7 over 8, and the other one is a negative 8 over 7. Those will be opposite reciprocals. And if it's neither, you'll see something like one is m is 1 over 5, and the other one is m is 7 over 5. But that's neither. Okay, so they're not the same and they're not opposite reciprocals. So very first thing, we're going to look at these two equations and we're going to write them in slope-intercept form because they're not already in slope-intercept form. The nice thing about slope-intercept form, which recalling is y equals mx plus b, is that the number that's been multiplied by your x, which is this m, that's your slope. But we can only identify this to be your slope if this equation is written in slope-intercept form. So y equals mx plus b. As this first equation stands as of now, we don't have the y by itself, or the y is not on one side of the equation by itself. So that says that this 4, even though it's being multiplied by the x, that is not your slope. So first, let's solve it for slope-intercept form so that we can identify the slope. So 4x plus y equals 5 is our first equation. In order to solve this for y, we need to first note that our y is here on the left-hand side of our equation. We want it to stay over there. So this 4x is not in the correct place, or in the place that it needs to be if y is going to be there by itself. So to get rid of 4x, we're going to subtract 4x on the left and subtract it on the right. We'll bring down our y, our equal sign, and then remembering combining like terms, 5 minus 4x, these are not like terms, so we write them separately, 5 minus 4x. In this case, we could go ahead and rearrange this if you'd like. It becomes y equals, putting our slope first, negative 4x. So negative 4x. And then this was a positive 5, so plus 5. This is our equation in slope-intercept form. And so now the number that's been multiplied by x, that's our slope. So m in this case is negative 4. So our slope is negative 4 for that first equation of number 1. For number 2, we are looking to once again solve this for y because it's not already in slope-intercept form. So to do that, we need to get our y term by itself. So let's leave this term on that side. And let's tackle first the 3x. To move it to the other side, we're going to subtract 3x on the left and subtract it on the right. 3x minus 3x cancels. We bring down our 12y. Bring down your equal sign. And once again, these are not like terms, so bring them down separately. Negative 6 minus 3x. And looking at our y term here, you can see that it is, again, not solved for y. So this is 12 times y. To undo 12 times y, we need to divide by 12 on the left. And what you do on the left, you do on the right. So divide by 12, divide by 12. 12 divided by 12 gives us 1. So we're left with 1y equals negative 6 divided by 12. We'll leave it as negative 6 over 12 for a second. And then minus 3 over 12x. Okay, we have some reducing to do for our fractions. So y equals 6 over 12. This reduces to a negative 1/2. And then minus 3 over 12 reduces to 1 over 4x. If you want to, it's a matter of preference. One, we can leave our answer just like this. And you'll just need to note that the slope is the number that is multiplied by the x, which will be negative 1/4. Or, if you prefer, you could write this as y equals a negative 1/4 x and then minus 1/2. And because this was negative 1/4 x, and then this negative 1/2 is the same as minus 1/2. So it's written both ways. Both ways are correct ways to write this particular answer. But even if you rewrote it, you'd still have that negative 1/4 is the number being multiplied by x. So it's your slope. So in this case, the slope is m equals negative 1 over 4. So our step now is to compare these two slopes. M equals negative 4 and m equals negative 1 over 4. As you're comparing, it's easy to compare the two fractions for one. So negative 4 is really the same as negative 4 over 1. So if you look at the two, you have a negative 4 over 1 and a negative 1 over 4. Think back to what we've learned about parallel and perpendicular lines. Parallel means they'll have the exact same slopes. Well, this is a negative 4 over 1. This is a negative 1 over 4. They are not the same. So they're not parallel. Okay, and then if you think about opposite reciprocals then, that means that one will be positive, the other will be negative. So in this case, you have a negative 4 over 1 and a negative 1/4. Well, both of these fractions are negative. So they are not perpendicular. Do note that 4 over 1 is the reciprocal of 1 over 4. But once again, because both fractions are negative, they are not opposites of each other. So this would be your classic neither case. Okay, they are neither parallel nor perpendicular. Let's try number 2. Number 2, we have negative 2x plus 7y equals 14. First step, isolate your y term. So we need to get rid of our negative 2x. And you should know that there's a pattern over and over again as far as what we are eliminating each time. So we're adding 2x to both sides to get rid of our negative 2x. We're going to bring down our 7y equals, we have that positive 2x and we have a positive 14 over here. Okay, 7 is being multiplied by y. Let's undo it by dividing everything by a 7. 7 over 7 gives us just y equals 2 over 7x plus 14 divided by 7. That gives us a 2. And we've solved it for y. So now the number multiplied by x is 2 over 7. So our slope is 2/7. It's the number we're going to reference here. We're going to compare it to our next slope for our second problem. So here we have 4x equals 14y. We want our y to be by itself. So notice that the term with the y in it is already on the right hand side of the equation all by itself. We only have 14y here. So we only have one step to take. 14 is being multiplied by y. So the opposite is to divide by 14 on both sides. 14 over 14 gives us 1. So left with y equals 4 over 14. That's going to reduce to 2 over 7x. So 2 over 7x. So y equals 2 over 7x. If you prefer to see y on the left side, then that's still just y equals 2 over 7x. Well, since slope-intercept form, x, the number being multiplied by x is 2 over 7. So let's go ahead and circle it. That's our slope. M is 2 over 7. Well, what do you know? 2 over 7 and 2 over 7 are the exact same fractions. So therefore, these two lines are parallel. Boom. We've completed number 2. All right. Numbers 3 and 4, you guys will try numbers 3 and 4. So please take a moment to pause the video, rearrange both equations within 3 and both equations within 4 so that y is by itself, and then identify those slopes. All right, so for number 3, we, after rearranging our equation, should have gotten y equals 1/2 x minus 2. Your slope is 1/2. It's the number being multiplied by x. For the second equation, y equals negative 2x plus 4. The slope is the number being multiplied by x, which is negative 2. So now we're comparing 1/2 to our negative 2. Well, let's look at negative 2 as a fraction. First off, negative 2 over 1. And let's check it out. This first fraction is totally positive, a positive 1/2. This second fraction is a negative 2 over 1. So it's got that opposite thing going on. One is positive and then the other fraction is negative. Opposite, boom, check. The next thing to check is to see if they are reciprocals. One is 1 over 2. The second one is a 2 over 1. Ooh, look at that. They also are reciprocals. Because they're opposites and reciprocals, this, or these lines, are perpendicular. Okay, so that's perpendicular. Pause your video once again and try number 4. Alright, so the very first equation in number 4 was already solved for y. We didn't have to do anything. Simply rewrote it. The second equation, we had to solve it for y. We needed to divide by 2, divide everything by 2. And so we got y equals 3x minus 3. Slope for both are m equals 3. So what does this mean, guys? They are parallel. They have the exact same slope. All right, so let's approach this problem in a little bit of a different way. We have, are the lines through each set of points parallel, perpendicular, and either, and explain your answer. So in this case, we're given two sets of ordered pairs. In number 1, we have the two sets, 5, -2, 4, -3. And then our second set will be 2, -3, and 3, -4. So first off, note that these first two are on line 1. And then your second two are for your line number 2. So you're trying to see if these two lines are actually parallel. So one thing that we learned back in lesson 1 is that we can use the formula m equals y2 minus y1 over x2 minus x1 when we're given ordered pairs. That's exactly what we'll do here. Here's our x1, y1, x2, y2. And note that we're going to do two separate problems all in one. So inserting our numbers into our formula, we'll have our -3, which is y2, minus our y1, which is -2, over x2, which is 4, minus x1, which is 5. Remember that when we're subtracting a negative, it's the same thing as adding. So -3 plus 2 will give us a -1, over 4 minus 5 gives us a -1. Okay, so a -1 divided by a -1 is actually the same as a +1 over 1. So our slope here is +1 over 1 for our first line. For our second line, let's do the exact same thing. Let's go ahead and label x1, y1, x2, y2. So m equals -4 minus -3 over 3 minus 2. We are subtracting a negative, so let's add those two top numbers. So -4 plus 3 gives us -1 over 3 minus 2 gives us a +1. So in this case, we have a -1 over 1 as our slope. So you're comparing a 1 over 1 to a -1 over 1. So notice that your first slope is a +1 over 1. The second one is a -1 over 1. So the opposite part, we got that going on. This one is positive, fully positive fraction. This one is a negative fraction. And then if you think about reciprocals, you have 1 over 1, flip that, you get 1 over 1. So these are opposites and reciprocals. So these two are perpendicular. And that's our answer for number 1. Right, so let's try number 2. Again, you've learned how to use the slope formula. Now we're breaking up our problem. And you guys are now finding the slope for the first line, and as well as the second line. Compare them. Are they parallel, perpendicular, or neither? All right, you should get that both of them have a slope of 1/3. So this means that those two lines are parallel to each other. Well, let's keep going. Number 3, which two lines are parallel? So if we're looking to figure out which two lines are parallel, remember, we're looking for same slopes. Okay, look for the same slope. So for letter A, we would need to actually solve this for y, get y by itself, so that we can go ahead and accurately identify the slope. So to do that, here is our y term. Note the only thing stopping the y from being by itself is the fact that it's been multiplied by this 4. So opposite operation says divide it by 4. If we divide the left by 4, divide everything on the right by 4. So you have y equals 3 over 4 minus 2 over 4x. Okay, that 2 over 4x can be simplified So really this equation would be y equals negative 1/2 x plus that 3/4. And I just rearranged it to put the slope in front and then the positive 3/4 on the back end. But here our slope would be a negative 1/2. Let's look at part B, because once again we're comparing all three of these to see which ones have the exact same slope. Let's go ahead and further write the slope in the first part, part A, will be negative 1/2. Let's figure out the other slopes. For B, once again, our 4y, the y term is just stopped from being by itself. The y is stopped from being by itself because the 4 has been multiplied with it. So let's divide by 4, divide by 4, divide by 4. So we'll have y equals 2/4x, reduces once again to 1/2 x minus 5/4. Our slope is the number being multiplied by x, and so in this case m equals 1/2. Okay, so far you should be able to see that these two are not the same. Negative 1/2 and 1/2 are not the same exact slopes. So far A and B are not parallel lines. Let's look at C. So once again, get your y by itself. Divide by 2. And so here we'll have y equals 4 divided by 2 is 2, plus there's a 1 in front of the x, so 1/2x. So in this case, the number being multiplied by x is 1/2, so our m equals 1/2. Now identify the two that are the same. Well, bingo! Letter B and letter C are the same. They have the same slopes. So in this case, which two lines are parallel? That's B and C. Those are your answers. All right, in number 4, which two lines are perpendicular? So for perpendicular, you should be thinking about opposite reciprocal slopes. Opposite reciprocal slopes. So the very first thing that we're going to need to do is solve each of our equations for y. Get your y by itself. So in letter A, we have the y term is negative 2y. So let's first get it by itself by removing our 3x. So subtract 3x on both sides. We're left with negative 2y equals negative 3x plus 5. Divide by negative 2. Divide by negative 2. Divide by negative 2. So we're left with y equals, this is negative 3 over a negative 2. Negative divided by a negative will give us a positive 3 over positive 2 x. And then we have a positive 5 divided by a negative 2. This will then turn into a negative 5/2. Because positive divided by negative is simply negative. So our slope for number or letter A is 3/2. So m equals 3/2. All right. For B, we'll have to divide by 2. And so y equals 4 divided by 2 is 2. Negative 3/2. And then our x. Here, our slope is the number being multiplied by x. So m equals negative 3/2. And then our last one, we have 6y equals negative 4x plus 2. Well, let's divide by 6 so that y is by itself. And we'll have y equals negative 4/6 reduces to negative 2/3x plus 2 over 6 reduces to 1/3. So our slope is the one being multiplied by x. So m equals -2 over 3. Take a moment. Which two are perpendicular? So you're looking for opposite reciprocals. Which two are perpendicular? Your answer should be A and C. A and C. You have the two numbers 3 over 2 for part A, or letter A was 3 over 2. And then letter C was a -2 over 3. So one was a positive fraction, 3 over 2. The other one is a -2 over 3. Then you have your 3 over 2 versus your 2 over 3. So they are also reciprocals. So A and C are your two answers. Lastly, we have application examples. These are simply word problems, but same concept or same skill. So on a map, Sandusky Street passes through coordinates -2, -1, and -4, 8. Pennsylvania Avenue passes through the coordinates 4, 11, and 6, 2. Describe how these streets intersect and explain how you know. So we're looking to see if these two streets run in the exact same direction. So are they parallel, or are these two streets perpendicular to each other? So we'll use our slope formula for both of our streets. So x1, y1, x2, y2. Label your points first. All right, remember that our formula is m equals y2 minus y1 over x2 minus x1. So for the first, we have 8 minus a -1 over -4 minus a -2. Subtracting negatives means that we're just going to add. And so we'll have 8 plus 1, which is 9. And -4 plus 2 gives us a -2. So this will get a -9 over 2 as our first slope. For the second one, first start off by labeling your points. x1, y1, x2, y2. And then enter them into your formula. So 2 minus 11 over 6 minus 4. 2 minus 11 is a -9 over 6 minus 4 is 2. So m equals -9 over 2. Well, if you look at it, you have a -9 over 2 for Sandusky as your slope. And then for Pennsylvania Avenue, we also have a -9 over 2. So in this case, our slopes are the same slope. And so that means that these are two parallel streets. All right, so for the last one, you have Washington Street and Adams Street. We're looking to see how these streets intersect. So are they parallel, or are they perpendicular, or neither? So please take a moment and identify the slopes of each of your lines. All right, and for these, you should see that Washington Street has a slope of 2 over 2, which gives us 1. And Adams Street has a slope of 1 over -1, which is equal to -1. If you think about both of these as fractions, you really have a 1 over 1, and you have a -1 over 1. In this case, when you're comparing, you have opposite reciprocals. One fraction was positive, +1 over 1, and one fraction was -1 over 1. And then reciprocals means that we've flipped the fractions. And in this case, 1 over 1 is the same thing as 1 over 1 flipped. So these are opposite reciprocals. So that means that these two streets are perpendicular to each other. And with that, we are done with our lesson 4.